Solving systems of equations using Laplace transform is possible. Let's say you have 2 or 3 or 5 equations in a certain problem. They are including x, x prime, y, and y prime, and homogeneous and non-homogeneous mix of equations together that you want to solve them using Laplace transformation. Maybe Laplace transformation is the best approach to use between the available methods of solving systems of equations. In order to learn how to do that during this lecture, let's start jumping into an example. Let's say you have equation number 1, x double prime minus 2xy x prime plus 3 multiplied by y prime plus 2 multiplied by y as a non-homogeneous equals to 4. This is equation number 1. Equation number 2, you have 2 multiplied by y prime minus x prime plus 3 multiplied by y equals 0. That's equation number 2. Now you want to solve this equation while you are given that the initial values x of 0 equals x prime of 0 equals y of 0 all equals to 0. That's given in your problem. This is a typical mid-level set of equations that need to be solved, and it could happen to be the Laplace transformation is the best approach to solve your problem. So in that case, if you want to go with the Laplace transformation as the best way of solving your equation, let's take the Laplace transformation of equation number 1. Equation number 1 over here. If you take Laplace transformation for this equation, you will have s squared multiplied by capital X. Same way when you do for the y prime and y double prime, but you are representing x in this case. Minus 2 multiplied by s multiplied by capital X plus 3s multiplied by y plus 3 multiplied by capital Y equals 4 over s. The right hand side is 4. That will transform based on the table to be 4 over s, and that can be called equation 1 prime. Now taking the Laplace transformation in the same manner for equation number 2, what will give us? It will give you 2 multiplied by s multiplied by capital Y minus s multiplied by x plus 3 multiplied by y equals to 0. That's equation 2 prime after doing Laplace transformation. Now, of course, what you're gonna do, you wanna solve for x of s and y of s. You wanna keep them on the left hand side of the equation and the rest on the right hand side of the equation. In this case, x of s, after doing a little manipulation, mathematical regular manipulation, that will give you 4s plus 6 over s squared multiplied by s plus 2 multiplied by s minus 1. You can call it equation 1 prime or don't need to call it at all. In the same manner, if you do simple mathematical manipulation, y of s would be 2 over s multiplied by s plus 2 multiplied by s minus 1. Now, as we learned previously, this x of s having several terms in the denominator and y of s have several terms in the denominator, that will raise a flag and rings a bell that we need to use partial fraction expansion to go back to our x of t and y of t values in the simplest form. using partial fraction. If you go with the partial fraction, what would happen? You would be able to find your x of t and y of t. So the partial fraction will give you x of s to equal minus 7 over 2 multiplied by 1 over s. We will not go deeply with the partial fraction, otherwise the lecture will be so long. We already talked about that in a specific video that you can refer to for more details. Minus 3 multiplied by 1 over s squared plus 1 over 6 multiplied by 1 over s plus 2 plus 10 over 3 multiplied by 1 over s minus 1. That's a long partial fraction. Same manner for the y of s after partial fraction. How does it look? It will give you minus 1 over s plus 1 over 3 multiplied by 1 over s plus 2 plus 2 over 3 multiplied by 1 over s minus 1. Now, with that being said, now referring back to the transformation table, we can easily find x of t as a final step and y of t, of course. X of t will be minus 7 over 2, 1 over s is 1, as you know, minus 3 multiplied by t plus 1 over 6 multiplied by e to the power of minus 2t plus 10 over 3, the same factor will stay the same, multiplied by e to the power of t. That was x of t, done. Y of t, partial fraction reverse transformation, gives you minus 1 plus 1 over 3 multiplied by e to the power of minus 2t plus 2 over 3 multiplied by e to the power of t, and that's your final solution for the system of equations mentioned in this example.